Welcome everyone to IPDay's Webinar Wednesdays. I'm June Rawl. Today our webinar is facilitated by Ronald Cruz. Before we get started, I wanted to remind you that this webinar and all IPDay webinars are recorded and can be viewed anytime. You can access these webinars on the IPDay website under Webinars. The webinar today is interactive and we would love for you to ask questions and voice your comments. Please feel free to do this throughout the webinar. Just simply enter them into the Q&A bar. Ron will be answering your questions throughout the webinar. As you know, there are several questions on the first part of the GED Mathematical Reasoning test that students are not able to use their calculators. These questions assess 8 indicators covering various concepts in number sense and computation. In today's webinar, we will tackle the competencies 1 through 4. But stay tuned and sign up for part 2 on November 2nd, where we will be addressing the final competencies 5 through 8. Today, Ron's going to explain the skills that we need to hone in on so that our students will be well equipped and prepared to answer these questions with ease. Ron, thank you so much for facilitating this webinar today. We appreciate your expertise and guidance. I'm going to turn the webinar over to you now, Ron.
Thank you, June. Thank you so much. Thank you, everyone, for tuning in for Webinar Wednesdays. Again, this is your webinar facilitator, Ron Cruz. Just wanted to briefly introduce myself. For those of you who have not been familiar with who I am from Tampa, Florida. I'm the coordinator of the Caribbean Refugee Program, which is an ESOL program here in Tampa Bay. We are part of the Hillsborough County Public Schools Adult Education Network of Schools. I am also a statewide trainer and facilitator for the contents of ESOL, APE, and GED through the Florida IPDay. I just wanted to again say that thank you for tuning in for today's webinar. Hopefully I will be able to impart some really useful information to you that you can take immediately and start using in your classroom. A lot of the things that we wonder about is those first 5 questions on the math module of the GED test. It has been such a great mystery to some of our teachers who are not always browsing through the GED testing service materials or not signed up for the newsletter that GED sends out. But very recently, the GED testing service released these 8 competencies that focuses on the non-calculator portion of the GED math module. So we're going to be talking about that today. So just to give you an idea of what we're going to dive into, first I'm going to talk about some housekeeping reminders. We'll talk about the objectives for this particular webinar. And then we're going to start off with Q1 indicators. So the first 4 calculator prohibited indicators are labeled as Q1 and also we'll be focusing on fractions and decimals, factors and multiples, rules of exponents, and distance on the number line. I'm going to quickly give you a brief overview of some resources that you can find available to you through the IPDay website, and then we'll summarize and evaluate this, this webinar. So without further ado, I'm going to go ahead and get started with today's topic. Starting with the things to remember. Just like June said, if you have any questions, you can simply click on the Q&A tab or button at the top of your screen, and it will populate a window where you can type your question. And I will be visiting this window periodically throughout the webinar. So don't feel frustrated that I haven't gotten to your question yet. There are certain points during this webinar that I'm going to be addressing these questions. But please keep them coming so that we can address whatever your concerns may be, because this is your webinar. Your microphones are currently muted. You are only on listen mode, so that in order to ensure that every participant in this webinar is able to clearly listen to what I have to say. and without any other interruptions or other noises that are coming out of different microphones. And today's presentation is also being recorded. It will be archived just like all the other webinars that I've conducted. It will be archived in the IPDay website, and it will be available within 48 hours. So if you have to go somewhere or you have to cut your webinar participation short, but you don't want to miss out on the rest of the materials, you can always come back and look at the archive. Or if you see that this webinar, if you find it very useful to your colleagues or to your students, maybe that you can always show and use this webinar archived for your own purposes. So let's start with our objectives. At the end of this webinar, my goal is to increase this, help you further support your students in increasing their performance, specifically on these first 5 items of the GED test. We're going to do a little bit of a quick review of the math concepts and skills. We're going to be doing some exercises here and there. Just to review of our math, of our rules, and a lot of these are going to be computational, mental math skills, and a lot of estimation is going to be involved in here as well. So those are the key strategies that we're going to be honing on in this webinar. And then we're going to just talk about best practices and explore some resources, what's out there in the internet, or what's in the IPDay website that would really help us address these needs. Specifically, if your student came back to you after the test and say, I really wish that I went over some of the non-calculator parts of the test. So just keep that in mind, that we will be encouraging your participation throughout this webinar. If you have some great ideas or things that you do to address certain non-calculator skills with this, feel free to type it on our Q&A bar, and I could share it to the rest of the participants. Again, this is your webinar, so feel free to add or voice your concern, or ask your question, or provide us with some suggestions on how you do it in your classroom. We're going to start off with the first one. It's Q1A, ordering fractions and decimals, including the ones on the number line. One of the key indicators, or how do you know that, is this questions will require students to compare or order numbers. They may be positive or negative numbers, or a combination of both. Just keep in mind that sometimes they will be asking some questions with or without the use of the number line. So we must be training our students first with the number line to allow them the visual perspective of where numbers are, specifically numbers that are decimal numbers, because students are quite familiar with integers and whole numbers. We need to focus on decimal numbers, radical numbers, perfect squares. Where are these numbers on the number line? Having a really big number line posted in the front of the room or on the floor for students to use, or for use during your discussion, is highly advisable, and I found them very, very engaging when we're talking about the number system and points on the number line. The number line just makes it so much easier for students to compare numbers just by their position. The farther you go to the right, the greater the number is, and the farther you go to the left, the smaller that number is, which is a very, very simple rule that you can share with your students when trying to compare numbers. But keep in mind, do not get stuck with the number line. You need to be able to develop some quantitative reasoning on the part of your students, estimation skills with your students as to, can I do these comparisons without the help of a number line? So initially, use the number line to scaffold your struggling students, but your high achieving students or higher functioning students should be able to function without the help or the aid of the number line. These are some recommendations, and strictly these are coming directly from what was released by GED Testing Service. So they advise the test takers to leverage their skills in comparing order and ordering positive fractions and decimals. Negatives is one area where students have a very difficult time plotting on a number line, just because it's in a reverse order. It's not something that they see normally every day. A lot of the things or real world examples of numbers that students deal with or we deal with are mostly in whole numbers or positive decimals. So we need to start practicing that with our students. Another thing is that, start practicing with your students how to compare a positive and a negative, and most importantly, a negative to a negative number. And I'm sure a lot of you already have some really good ideas on how you develop these quantitative skills and comparison techniques with your students. So feel free to share that with us as we go along. So we're going to start off with some sample problems here. So the first sample problem is asking us to order these numbers in order of least to greatest. So really what students need to pay attention is sometimes they're asking the student to order them from least to greatest, sometimes in reverse order, or they would probably ask the students to figure out which ones are equivalent. So what I advise the students, and when they see problems like these, is to really write down or jot down on their noteboards what are they being asked to do. So really in this particular problem, we're being asked to order these numbers from least to greatest, from the smallest to the largest. That's another thing that I practice with my students is to, can you say the question or restate the problem or the question in your own words? So in this case, we first survey the numbers. It's like, okay, I see negative numbers, a couple of negative numbers, so negative 0.2 and negative 1/2. I see a 0 right towards the end. So I don't know if you can see my mouse. Okay, I see a 0 right here. And then I see some positive fractions, fractions that where the numerator is less than the denominator. So I know that they're going to be less than 1. And then I see the number 1 here. And I also have here a decimal number that it does not have a whole number in the front, does not have a negative number in the front. So I know this is going to be between 0 and 1. So what I just did with you is just a quick mental browsing of all of the given numbers. So I've kind of like examined what was given to me, and then I wanted to do at what point of attack should I do this. So now I know that the smallest numbers are going to be these two negative numbers right at the front. So now my biggest question now is, which one is smaller? Is it negative 0.2 or negative 2/10 or negative 1/2? Okay, well, students, 1/2 is pretty easy and quite straightforward fraction that they can always associate 1/2 to a 0.5 or 0.50 or 50%, something like that. So I'm going to go ahead and rewrite the 1/2, negative 1/2 to negative 0.5. I'm just going to tilt my screen here a little bit to allow me to write. Okay. So in this case, I'm going to have negative 0.5. So that's going to be where my 1/2 is, my negative 1/2 is. And then I'm going to keep this negative 0.2. So now, in this case, I could clearly see now that they're both in decimals, I could now clearly see just by point blank which one is a bigger and a smaller number. Just keep in mind that these are both negative numbers. So the higher the value is, the smaller it is. So the rule reverses for negatives. So I know now that my smallest number, and I'm going to write it over here. This is going to be my scratch section, the left side, and then my final answer would be on the right side. So I'm going to see, now I know that my smallest number is negative 0.5, followed by the next number, which is the next smallest number, which is still a negative 0.2. I hope you can clearly see. I don't know if I have to adjust the thickness of my my pen, but just put it in the comments if I have to, if it's not clear enough that you can't see my writing. So now I can now deal with the number that is beyond the negative side. So right after negatives is going to be the 0. So I normally do this, and I know some of your students, you notice it too, that sometimes after they place the number, they're going to go ahead and scratch them off like this. So now I have taken care of that number. Now it's going to be followed by the 0. I know the 0 is going to be the dividing number between all of my negative numbers onto the left, and then all of my positive numbers to the right. Students will have an automatic thinking that way if you practice this enough with your number line. So now I'm going to deal with the 3 other numbers. I know 1 is going to be my greatest number, just like what I did earlier with my mental math or my scanning the problem technique as to what's given to me. So I know 1 is going to be the last number here in my answer. So I'm not going to deal with that yet. I'm going to talk about this one, the 0.6, the 1/3, and the 1/6. So now let's talk about this. A little bit of mental math here, and then a little bit of fractions, keeping in mind that when I'm talking about decimals, as the denominators, I'm just talking about these 2 fractions right here. As the numbers become greater at the denominator, what happens to the fraction? So I asked that student, and sometimes I would ask them to draw me 1/3 and draw me 1/6, and tell me which one has a smaller piece. And they would always say, okay, well, as your numbers get bigger in the denominator, the piece of the pie or the piece of the square or rectangle gets smaller and smaller. So I know now from the fact this is going to be a small number, and this is going to be the big fraction. So it's a small fraction and a big fraction. The question is it bigger or smaller than 0.6? Well, another way that I'm going to use the 1/2 as an indicator, because I know that 0.6 is greater than 0.5, which is half, 1/2. So I'm just going to compare them. I'm just going to compare them with respect to the 0.5. So I know 1/3 and 1/6 are less than 1/2 because the denominator of 1/2 is 2. So I already know that. So my second to the last, so I already know that 1 is going to be the last answer here. I already know that this one is 0.6, the second largest. So now it's just a question between 2 numbers, 1/3 and 1/6. There's another technique that works quite well for students when comparing fractions, if they don't know which one is smaller and bigger, is cross multiplication. Okay, so this, if you cross multiply 6 times 1, that's going to be a 6, and 3 times 1 is a 3. So since this is a bigger number, the left side generated the bigger number, so I know 1/3 is the biggest, or the bigger number, and then the 1/6 is the smaller number. So now I have that. So now I know that it took me quite a long time to get to this answer, but remember, I'm having to talk out loud. I'm talking about the math. The reasoning behind one is greater than another, and all of that. I would like, and what I do is I want my students to do the same thing when they're ordering numbers from least to greatest or greatest to least, is to have that mathematical conversation with themselves as to try to figure out the best point of attack to a particular problem. So I know it took me a little longer explaining it, but that's the way that I want my students to do it, is to explain it out loud to me, tell me what they're thinking, how they're doing it, so I can provide the necessary feedback to correct if there are any errors in their thinking. And then let's look at the next set of problems. In here, I don't have the clue of any negative numbers here, so that doesn't make it any easier here. But if there are any numbers here that I'm going to be able to simplify. So what I normally do is everything else that I can simplify, I try to. Like, for example, the square root of 4. I could already take the square root of 4 and write 2. And we're going to discuss about radicals on the part 2. But just for this case, let's just say most of the students already know that the square root of 4 is 2. And then I have a mixed number here. and then you see a number here that kind of looks like a fraction, but you're not sure, keep in mind that sometimes it's going to be, numbers are going to be printed in classic print, which is this 11 over 5, or it's going to be in the math print, which looks like this mixed number right here, the 1 and 4/5. So this is your math print on your calculator, and then the 11 over 5 is your classic, the classic mode. Just keep in mind on the test, the GED test might interchangeably use between these two formats, just to see how students are familiar with the different notations of fractions or mixed numbers. So I see this is a mixed number. I can simplify that. So let me change that number to either a decimal, if that's easy for them, or a fraction. For me, I'd like to keep them as a fraction, so I'm going to do a quick thing that I usually teach my students is I multiply okay. So I put an X and a plus at the top. So I multiply the denominator by the whole number and then add the numerator. So 5 times 1 is 5, plus 4 is 9, and then I divide, and then I write it, and I keep the denominator the same. So I'm going to write it as like that. So I rewrote my mixed number, but I want to keep my improper fractions the same. So now I can compare these two fractions. I see that both fractions have the same denominator. So in this case, I'm now just going to start focus on the numerator. And when they're improper fractions with the same denominator, the greater the numerator is, the greater your fraction is. So I know now that the 11 over 5 will come before 9/5. Okay? And then the other question is, I'm going to order them later on. So I'm going to go and try to do this. Just keep in mind that pi, and students will automatically think that's 3.14. Keep in mind that pi is a non-terminating, non-repeating number, or decimal number with the whole number 3, and that this decimal can extend as far as it could. But right now, I'm going to just write it as an approximation right now. This one, the last one, is our third number, is 3.2. I don't have to rewrite that. So my next question is there any number here, okay, that is greater than 3? Okay, so why 3? Because 3 is my highest whole number in this set. Okay, 11 over 5 and 9 over 5, how do I know if it's greater than 3? Well, how many times does 5 go as a whole into 9? It can only go to 9 one time. And then 5 in here, the 11 over 5 can only go to 11 2 times here. So I know these two numbers are going to be less than 3. So these two numbers to the right, I'm just now going to compare it. Even though the pi number does not terminate or repeat or terminate, I know that when we're comparing decimals, we're comparing from decimal places from left to right. So the first decimal place here and the first decimal place on the 3.2, I have a clear indication that 2 is much greater than 1 as with 3.14. So I know that 3.2 is going to be my greatest number, and then pi will be my second greatest. I'm going to cross those out over here. So now I'm just going to place these. And I kind of already answered that question to you in a little bit, because if you go and you ask yourself, how many times does 5 go into 9? And you say, well, 5 can only go into 9 one time. And then how many times would 5 go into 11? That can go 2 times. And then you will still have a remainder. So that gives me a clue as to how I'm going to order these 3 numbers that are left. So I know I'm going to put 2 right in the middle, and then the 11 over 5, which I'm going to write over here. Oh, sorry. Let me erase that. Because it is from greatest to least. So it's in the reverse order. So I'm just going to erase that real quick. Okay, so I know that the next number that's going to follow that, the pi, the next least number, is going to be 11/5. And I'm going to follow the format that's written there. And then lastly, the smallest number would be 1 4/5. Notice that I did not write 9/5 because you have to follow how they're given up here. Okay, so you're going to have to follow that. So I did make a mistake right here because this is not supposed to be a 2. That's supposed to be a square root of 4. So you have to follow what was given to you. Let me just quickly erase that. Very good. All right, so that's the order. Let me just put the square root of 4 right where it is. All right. So now that you know the ordering of these numbers, you can easily, students can easily, if you practice this enough, students can easily plot these points now that you have in particular order. So I know that my greatest number is a 3, and then my least number is negative 0.5. So I want to have enough space as possible. So I'm going to put a 3 right here. And then I'm going to put negative 1 right here. And then I'm just going to do in increments. Hopefully this is proportional. Okay, so this is going to be my 0, my 1, and then my 2. And then your students can now just start plotting them as they see them. This is from greatest to least. The bottom portion is from greatest to least. The top portion is from least to greatest. So I'm going to start over there at the top portion. Negative 0.5 falls right smack in between negative 1 and 0. I'm going to put a dot right there, negative 0.5. And then negative 0.2, since it's greater, should be closer to 0, but at the same time, it has to be in between negative 0.5 and 0. So this is going to be over here. All right, so then my 0 is my next dot. And then I'm going into 1/6 and to 1/3. So I'm going to look at this whole line right here between 0 and 1. And I know I have to cut it into thirds because third is the higher number. And then I'm just going to cut it, just slightly cutting it into a third right there. So I know where my 1/3 is. And then from that point, I can go to 1/6, which is halfway between 0 and 1/3. Okay, and you need to be having these types of conversation with your students as to where they are. And then my next number is number 1. And then following now from the greatest number, I'm going to go from here going back. 3.2 is just a little bit over 3. So I'm just going to put a dot right there and put 3.2. And then I have pi, 3.1. So it's going to be really, really close. So I'm going to try my best to just to illustrate to you where the 3.14 dot something. Okay, so just keep in mind that this is an approximation of pi. So, and really and truly, you shouldn't be writing that. You should be writing just pi right there. Okay, and then now you go into the distance between the 11/5 and the square root of 4. I can plot square root of 4 right away. I'm just going to put square root of 4 right there. And then 1 and 4/5. Okay, so that is slightly, you can divide this whole thing into 5. Take marks.
Okay, I did not divide that very equally, but you get the point. 11 over 5, so that's, we already, 1 and 4/5, we already are going to be right here. And then the 11 over 5, okay, I'm sorry. Yes. All right. And then you have your 11/5 over here. And how you're going to do the 11/5 is, again, you can also divide this into 5 sections, and then you can count from the 0 going up, and then you'll see that your 11/5 is right here. All right, so right now I'm just going to pause for a minute and allow you guys to ask some questions, provide some feedback before we move on to our next indicator. Right now, I have one. Okay, it's not really a question, it's a comment. Very good. So I know that some of you are seeing this very clearly. So thanks for sharing that it is kind of clear in your view of the screen. It's clear on my side, so I just want to make sure that you are seeing this on your side as well. All right. And again, keep in mind, I'll be pausing at every indicator right after we solve some problems before we move on to our next indicator. All right, so this is our next indicator. Apply a number of properties involving multiples and factors, such as using the least common multiple, greatest common factor, or distributive property to rewrite numeric expressions. So again, just by summarizing this, it's just talking about least common multiple and greatest common factor, how it relates to the distributive property. We need to be doing those types of exercises with the students. According to GED, this is test takers generally perform well on this indicator. They don't actually have any specific recommendations provided to test takers or to teachers. So let's just quickly just find out look at some sample problems here. In here, sometimes students would immediately jump in and start solving the problem without even reading what it's asking for. In this case, let's read and figure out what that first problem is really asking. Is it asking us to solve the subtraction problem, or is it asking us for a different thing? And in this case, we're looking for the least common multiple. So let's let that sink for a minute. Least common multiple. How do we find that? Well, the step of finding a least common multiple is actually one of the most common ways for you to perform subtraction of fractions with unlike denominators. So that's really the most common way. A lot of students have already, especially your high achieving students, would automatically do this. So I'm like, oh, they would automatically multiply the both denominators and say will be 24 and then 24, and then we just rewrite this entire thing if they're solving it, okay? They're not addressing this question. And then try to figure out what the numerator would be so that it will equal 7 over 6 and 1/4 respectively. So sometimes, okay, well, if you divide 24 by 6, you get 4, and then you multiply it by 7, and you get 28 for that matter. And then you do the same thing here. 24 divided by 4 is 6, and then you multiply it by the numerator of 1, and that's going to be 6. But that's not what this problem is asking for. Neither is 24 the least common multiple, and that's just what I'm saying as my point while I went off on a tangent here, is because 24 is not the least common multiple. Although it is a tool that will help the students solve this problem, at the end, if they did not use the least common multiple, they will still have to simplify the final answer if they do. So let's just focus on the least common multiple in general. like, okay, what really is the least common multiple? Well, the least common multiple is easy, just like what it says. What is the least common between the two numbers if you start doing the multiple? So I'm just going to go erase this. That's not what we're trying to do here. And then go back to my pen. All right, so we're going to take the 6, and then we're going to try to find out all of the multiples of 6. So we're starting off with 6, and then 6 times 2 is 12, and then 6 times 3 is 18, and 6 times 4 is 24. So these are the first 4 multiples of 6. And you may have to sometimes go farther, okay, to find one. But in this case, we're just going to stop at 24, and if we don't find something common with the 4, then we can go further. So we can do the 4 this time. What are the multiples of 4? Well, we'll start off with the smallest, which is 4. Times 2 will be 8. Okay, 4 times 3 is 12. And then 4 times 4 is 16. Just by the listing of these, you can clearly see that 12 is the smallest number that is common to both multiples of 6 and multiples of 4. So the answer to this question is 12. Okay, so let's move on to the next problem. Okay, so finding the greatest common factor. So find the greatest common factor that will help us reduce the fraction below into its simplest form. Okay, well, when we're trying to reduce something into simplest form, we're trying to find as many ways as we can. Students love doing this, but we're trying to find, if we're doing the greatest common factor, we're going to focus on this denominator right here, and we're going to look at also the numerator. Okay, so okay, well, let's list down some of the common factors of 12. So meaning numbers that divide equally into 12, and those are, let's see, well, I'm not going to write, yes, I'm going to try to do that. So 2 is a factor of 12 because 2 times 6 is 12. So those are 2 factors of 12. So what else can multiply equally into 12? Well, can we try 3? Yes, 3 will work. And because 3 times 4 is equal to 12, so are these the only factors of 12? So I asked my students, okay, are these the only ones? You know, sometimes students will forget to figure out that 1. Okay, I have to tilt my screen a little bit so I can write. Students will see that 1 and 12 are also factors of 12. Okay, so now let's talk about 45. As your number gets bigger, it gets harder. So now I have the 45, so I already learned it from the 12 that 1 and 45 will be factors of 12. You know, and then I know that we can start dividing, by the way. So we can divide, well, 45, I can try dividing by 3. If you divide 45 by 3, you get 15. So I know 3 and 15 are factors of 45. Are there any other numbers that are factors of 45? Okay, so I keep asking my students, are there any other number there that you... Okay, 5. There you go. So, so if you do, and ask yourself, well, how many 5s go into 45? Then you'll see that there's also the 5 and the 9. Okay, so now that we have the listing of the common factors of both 12 and 45, now we can see, okay, well, what is the greatest? Okay, so in here I see a 1, 2, 3, 4, 6, and 12, and I see a 1, 3, 5, 9, 15, 45. The only number that I see that is common between my numerator and the denominator that is the largest is 3. And then lastly, we're going to go into a factor tree. Actually, factor tree is a really good way or technique for your students that you can do with your students in order to get them well versed with factorization or getting the prime factors or just simply factoring in general. So this is kind of like the basic idea of, so I'm going to write 72 right here. And just like the word says, it's a factor tree. So let's find two numbers that equally, when you multiply together would result to 72. And I'm going to try to, hit as big numbers as possible. So 8 times 9. All right, so then after that, we're going to go in and break down these two numbers, 8 and 9, into smaller factors. So we're going to start off with 8. Give me two numbers that would result to 8. Well, okay, that's 2 times 4. And how about 9? Okay, well, yes, that's 3 times 3. Okay, even though your students will be tempted to say, well, can we use 9 times 1? When you use 9 times 1, that does not do you any favors in trying to get the prime factorization. So when we do the prime factorization, we try to avoid 1 and the number itself. We're trying to break it down to other numbers other than 1 in itself. And that's kind of like the clue here when you're trying to do your factor tree. So now, looking at here, are there any other numbers that can still break down or can still be broken down into two smaller factors? 2 is the only factors of 2 are 2 and 1. So I can't break this down any further, so I'm just going to bring that down. But, however, I can break down 4 as to 2 times 2. Okay? 3 is another number just like 2 that cannot be broken down anymore. So I'm just going to bring those numbers again. The only factors of 3 are 1 and 3. Some students like drawing arrows because sometimes they would confuse the lines as numbers. So I sometimes encourage my students to draw arrows so that they know which ones are numbers and which ones are arrows, or which ones are actually branches of the tree that we try to draw. So just like the name, the name says, it's always it's a tree. So you're breaking down every number as much as you can, so that all you're getting are the smallest number that do not have any other factors other than 1 in itself. And then you go down to the definition of what is a prime number. And so actually, when I teach students prime numbers, I don't really teach exactly what prime numbers are. I let them figure it out by asking them to do a factor tree. And then from that point, they can figure out, oh, so these are the numbers that cannot be broken down any further, and we will call them prime numbers. Now, in some books or in some text, this will be written as 2 to the 3rd power times 3 to the 2nd power. If we just wanted to ask to simplify. And we are going to get to the rules of exponents. That's not the topic for today. I'm just letting you know right now that sometimes students may be asked to write it in this format. All right, so I'm just going to pause right here for a moment and visit our Q&A section of the screen just to see if we have any questions. Oh, okay. There's a question here from Miss Cameron. Approximately how many minutes do the students have for these questions? That's really hard to answer. There is no time. The time that is given to them builds in this first 5 questions. So really, the longer they take with those 5 questions, the less time they have for the rest of the test. And I have here a suggestion here from another teacher named Joseph Tucker, or another participant. I don't know if he's a teacher. His name is Mr. Joseph Tucker. He said, I teach students to factor using the lowest prime until they can't do it, then try the next larger prime next time, etc., etc. That's really a great suggestion, Mr. Tucker. I interchange my strategies every now and then. It's always it's always useful to build upon what students already know. So once I've taught them the prime factorization, let's say of 72, then we go into a next larger prime number. So before they get into the 72, we would already have we've already discussed all the other numbers or several examples that are less than 72. And then from this point on, after teaching 72 and the prime factorization of 72, I'll probably try, let's say, 99 or 100, something that's a little bit more common. Okay, so I have a question here from Josephine Day. How do you get a printout of the question, or can it be sent by email? Does these webinars count as credit or in service points for certification? The answer is yes and yes. Josephine, the questions are actually, I put them in a worksheet format, and they are accessible. I'm going to show them to you at the end how you can access them. Once you register for this webinar, you automatically get access to all of the handouts, and all of these questions that I'm going over are actually a worksheet in a worksheet format. So you can do this with your students. And then we're talking about in-service credit and in-service points. If you do register for this webinar through the IPDAY website, through your portal, it collects all of your in-service points. It collects all of your participation in either face-to-face workshops or webinars, and it gets bounced back to you. You can print them out, you can access them anytime, print them out and show them to your administrator as proof of your attendance or participation. And maybe I can turn this a little bit to June Rawl, who can give us a little bit of an idea about that in-service credit points for this webinar. June, do you want to chime in?
Ron, it's really up to the local provider. IPDAY is the resource center, and you're right, it's all in the portal activity. It's in a transcript form, so they can present that to their supervisor. But as far as how many points or how many, credits you get, that's really up to you to present that transcript to your supervisor, because it's a local decision.
Correct. Thank you so much, June. And if you need help accessing your portal, you can always call the helpline or the support number at the bottom of the IPDAY website page if you access www.floridaipday.org. And you can access, you can call the person, somebody will be with you, walk you through the process, help you with resetting your password and things like that. So if you do get into a pickle, you always have a telephone number or an email to contact to help you trying to get these in-service points. So we're going to go ahead and move on. We don't want to spend too much time on that. And hopefully I was able to answer some of your questions. I'm going to pause again after this next one to get some more questions from you. I do want to be cognizant of the time. The next one is rules on exponents. So really and truly, there are three major rules that the GED testing service would want us to really emphasize. There's more than three if you factor in not radical, but if you factor in negative exponents and fractional exponents. So there's really quite a bit of rules and exponents. So it really does a great favor if we're going to go ahead and practice these things. So in here, we can have a name for these. So the first one is kind of called a power rule. And then the second one is called a product rule. And the last one is a quotient rule. And these rules, the way we handle exponents and the way we handle other things like logarithms and all the way going into calculus follows these same three major rules. You'll see that you'll have some power, quotient, and product rules when you go into calculus, power, product, and quotient rule when you go to logarithms. Although those are not covered by the GED test, it's good to know that these are lingering understanding, that the more you teach them, these rules, they're going to keep using these rules regardless of topic or content they're going to be going through in math. And these are some of the suggestions for test takers. Just practice them with the powers, practice them with the rules, learn to calculate with coefficients, try practicing with negative powers, experiment with fractional powers. Although you wanted to use the more common fractional powers such as 1/2 and 1/3, which is within the scope of the GED test, which is square roots and cube roots, which will be covered on part 2 of this webinar, and also multiple operations, which I'm going to show you on the next slide. So these are some of the example. Again, very strictly, power rule is being applied on the first problem. If the bases are the same and there are no coefficients involved, we simply add the exponents. So we keep the same base and we add the exponents. So I'm just going to illustrate how I'm going to add the exponents 3 plus 2, and that will come out to be x to the 5th power. The next problem is a little bit more tricky because this is also the same as the first problem because the bases are the same. Students might not see that right at the first glance because of the parentheses, but keep in mind the parentheses indicate multiplication if there's no operation in between. So this could be rewritten as 3 to the 2nd power times 3 to the negative 5th power. And then the same follows the rule. If the bases are the same, we keep the base and we simply add the exponent. So I'm going to illustrate 2 plus a negative 5. And this is where your operations on integers come to take place, that when the numbers are different, if you're adding a positive and a negative number, that's what I mean, you are going to subtract them and keep the sign of the bigger number. So this will still result to 3 is the base. The base will not change. The exponents will. So the 2 plus a negative 5 will come out to a negative 3. Now, some students would push this even further, those who of your advanced students, and say that this is also equal to 1 over 3 to the 3rd power. So that's something that you want your students to build up on, which will be in here. When the powers are negative, you can bring that number, the base, to the denominator and make the power positive. Just keep in mind, don't forget to put a 1 as a coefficient. So we're going to practice that on the next problem. So this is x to the negative 1. So I'm going to rewrite that as x is 1 over x to the 1st power. And then I'm multiplying it by the same. I'm going to follow the same procedure here. So I'm going to put a 1 at the top, bring that down, and keep a positive. Students quite like this idea because they hate working with negatives. You know, so that's one approach. But keep in mind that students can go ahead and go straight forward and keep the base the same and just add the numerators. I mean, the exponents. I'm sorry. I'm still in the fraction world here. So x to the negative 1 plus a negative 4. So either way will result to the same number. So whether you wanted to work only with positive numbers and doing it this way and also practicing the negative power rule, the students sometimes they don't like to do that, so they can do this. Just keep in mind there is no one correct way. You know, it's not so much as the final, you know, there's many ways to come to the correct answer. So in here, I can simply add the exponent negative 1 to negative 4. Oh, that's easy because they're both negatives, so I can just simply add them together and keep that. Either way, some of your students will still come up and say, okay, well, I can rewrite that with a positive exponent, 1 over x to the 5th power. So both of these could be taken as a correct answer. If you have here the power rule, when you have a power raised to a power, then you're going to have to multiply the exponents. You're not going to add them anymore. So this is just equal to x 3 times 5, so which is equal to x to the 15th. So very straightforward application of that rule. We're going to do the same thing here at the next number. The base is the same. Notice that I'm not doing anything to my base. That's one of the biggest misconceptions of the students when working with exponents, that something's going to happen to that base. And no, the number stays the same. If you're working with exponents, you're only working with the exponents. Not unless I want you to evaluate exactly what is. For example, taking this number over here, what is that exactly? Well, and then I can do that. That's 1 over 9. Yes. So that's that, you know, unless the problem strictly asks you to write it in a fraction without any exponents, then you're going to have to really evaluate. That's when the base disappears. But in the cases where you only have to simplify them, you're going to want to keep the bases the same so you're able to work with them throughout. So in here, you still have the 3 as your exponent. I'm going to change that to a multiplication and then a -2. Or I can write this like 3 to the 3rd power times -2. And then you can work off of the powers. So 3 to the -6. A positive times a negative is a negative. Or I sometimes tell my students, if there are unlike signs, you're always going to get a negative. And then some of your students you'll be good at this answer, but maybe the question will ask, well, without any negative exponents. So then you're going to have to push this further and change this to in the format of only positive exponents. And then lastly, now that we have the coefficients. When we have coefficients, my technique is just to separate that coefficient, because that coefficient doesn't have anything to do with any of your exponents involved. So I'm just going to keep that 5 away, but I'll just keep in mind that I have to put that 5 back in there once I simplify. So I'm only simply working right now with x to the 3rd times 1/2. Again, I'm applying the power rule in this case. Students can write this and multiply across. They can write an over 1 and then multiply across, and that's going to come out to x to the 3/2. Okay, so 3 times 1 is 3, and then 1 times 2 is 2. That's how I got the 3/2, and then I just put the 5 back in there. All right, and then we're going to go to our last rule, which is kind of like one of our very easy and really straightforward indicators here in our question and answer. Now I have a little bit more questions here. I have a little suggestion from Mr. Tucker. And he has some suggestion as to allow the students to experiment with the numbers to get them a little bit more understanding of exponents, and that's good. Oh, I'm so sorry. Yes, that is true. I made the common mistake. It is not 1/3, 1 to, okay, let me make that correction. Okay, this one is 1 over 27, not 1 over 9. Okay, I was very quickly moving along with the numbers. I forgot that. Okay, so again, that's 1 to the 3rd power. 3 to the 3rd power is 27, and it's not 9. I kind of illustrated there a more common mistake of what students would do. Thank you so much for that feedback, and I'm going to move on to the last one. In here, they're just talking about absolute value of a rational number. Students need to understand that in order to know a little bit more about distance and answer questions concerning distance. They do have some recommendations, calculating distances between 2 points, especially using the number line. Calculate with all types of numbers, not just whole numbers, but include integers, decimals, and fractions as well. And I went and pushed that a little further and added in the pi there and also the square roots. And then focus on the concept of creating and identifying absolute value expressions that model distance. So that would be best illustrated in our next question. Again, trying to go slowly with their first time seeing absolute values. In here, in this case, if we're trying to find and simplify the absolute value of -4, of course, if it's a negative number, it will change into a positive. And again, in here, the next question would be the negative of the absolute value of -3. So when dealing with problems like this, you put the negative sign first, and evaluate what's inside the absolute value, and that is a 3. So your answer is still going to remain negative. And in here, the next one, they will follow the order of and how to the order of operations. That's what I was looking for. So when they're evaluating a string of expression, a string of numbers, they need to be following also the order of operations. So based on the order of operations, a lot of students know that PEMDAS is the best way for them to remember that. Please excuse my dear Aunt Sally. So parentheses, in this case, our parentheses is the absolute value. So the absolute value can be used as a grouping symbol. And then so we have 3 to the second power minus 10 inside the grouping symbol. So then we do the E stands for exponents. So we do 3 to the second power. This one is the 9. So I'm just going to write this down. 9 minus 10, and then the absolute value. And then we evaluate again what is in here. And then 9 minus 10 is a negative 1. So we're just going to write it like this. And then the absolute value of negative 1 is 1. So 1 times the number negative 2 is still going to be a negative 2. All right, and then find the distance of 2 points. This is usually very useful to the students if we have a number line. They see the physical illustration of the distance. And keep in mind that when we're talking about distance, distance is a positive number. Or if we wanted to state that easier, we want our students to plot these points into the number line and then count the number of spaces in between to figure out how far they are from each other. So in this case, negative 9 is going to be somewhere here. Negative 5, negative 6, 7, 8. So let's just say this is negative 9 over here, and then negative 3 is right here. And then you just figure out how many spaces. So there are 6 spaces there. I'm going to keep that as a positive number. Another way is sometimes it will be asked to write an expression for the distance. And keeping in mind that the distance between the numbers respectively is the difference, the absolute value of the difference of the two numbers. So if I wanted to find the distance in this third problem between negative 11 and negative 2 is the absolute value of the difference. So it's negative 11 minus negative 2. Keep in mind that, again, distance correlates to the word difference. And difference is subtraction. So I simply subtract the negative 11, negative 11 minus negative 2, and then I take the absolute value of that answer. This question does not ask us to figure what it is. They're just asking us to find that expression. Okay, so let's go ahead and look at our last few questions here. Okay, very good. So we don't have any other new questions here. So let's go ahead and summarize everything that we've talked about. We've explored about some calculator prohibited indicators, strictly the first 4. We did some review of math and some example problems that we can do with our students. There is a worksheet that you can download and immediately print out and give to your students. There is also an answer key that is there. If you want the answer key for the second part, you're going to have to tune in for part 2 of this webinar. And the last thing I wanted you to do is, if you have a phone and you have a scanner on your phone, you can scan the QR code on your screen, or type this webinar evaluation SurveyMonkey survey. Your feedback is so important to us. We would like to know what we did well, what we didn't do quite as well in this webinar.
We do take a lot of consideration of what you say. Hopefully I was able to impart some really useful information and a little brief review of mathematics with you. And hopefully you can use the resources and materials that I provided with your students. And again, just like I said, thank you very much for spending your afternoon with us. The rest of the IPDay team would like to share with you our thanks. And again, the QR code is still on your screen. We're going to keep it posted for a little while here. And then again, the Survey Monkey link is at the bottom. If just in case you cannot, this webinar has already terminated or the broadcast has terminated, keep in mind that the Survey Monkey web address is also in your handouts that you can download from the IPDay website. Again, thank you so much for your participation, and stay tuned for part 2 of this webinar.